In this lesson, we're looking at applications of trigonometry. And when we're talking about applications, we're talking about real world scenarios. So in this case, we're going to look at angles of elevation and angles of depression. Now, straight away, angles of elevation mean that we are looking up to something. So they are measured up from the horizontal, right? Here's our horizontal. We're measuring up from the horizontal. So here's a tree, we've got a wire supporting it, and we are trying to figure out how long that wire is going to be if it's on an angle of 14 degrees and it's 6 meters away. The opposite of this is an angle of depression, and that's still measured down from the horizontal, right? It is down from the horizontal. So even though we would look at this situation and say, okay, I'm standing on top of a cliff, I'm looking down at a boat, I'm looking down at the boat, this is our triangle. We would usually want to go, this is the angle that we're looking at. But in this case, it's not. We're looking at the other one on the outside of the triangle. Okay, let's solve this one. So we have to draw a triangle to start with. So here's my triangle. This is the situation I'm looking at. I know that this is my x, this is 6, and this angle of elevation is 14. So we can write our information. We know theta is 14. We know that this is the adjacent side, so A equals 6. And we know that the hypotenuse, is the one we were trying to find. So an A and an H, we know we need to use cos of theta equals A on H. We can now substitute in, we can say cos of 14 is equal to 6 on X. We would need to rearrange, which means we'd need to do this switch here. So we'd end up with X equals 6 divided by cos of 14. And on my calculator before, it said it was 6.18 meters, right? So it's the same idea. We've got a real world scenario, but we still need to draw your triangle, label your sides, write your information and pick a rule, substitute and solve, right? Let's do this one, a bit more tricky this time. So we've got our angle of elevation, depression. But remember, we are looking down and we have the outside angle here. What we know about this, however, is if we add the outside angle to the inside angle, it will give us this right angle, because the vertical and the horizontal will always make a 90-degree angle together. So we can determine if this one's 20, then theta is going to equal 90 take 20, and that means the inside angle will be 70. So the triangle that we are drawing looks like this. Here's our right angle up here. We now know that theta is 70, and we probably need a bit more information, right? So let's say the cliff is 15 meters high, and we are trying to figure out how far away the boat is, okay? So let's do some information here. We've got this is our opposite side, this is our adjacent side, and our theta is right here at 70. So we've got theta equals 70, A equals 50, and X is our opposite side, so it's our unknown. So we'd need to use tan there for the O and the A. So tan of theta equals O on A. Tan of 70 equals the X on the 50. And we can move this 50 over here because we only ever move the bottom of the fraction. So 50 times tan of 70 equals X. So our X on my calculator before, it said it was 137 meters. Okay, so angles of elevation from the horizontal up, right? Here we go, there's our up arrow. Angles of depression from the horizontal down. We have to be careful that we're looking at the inside of the triangle angle, not just the outside of the triangle. We might need to redraw our pictures each time. And we have all the different ways of rearranging to find sides still. So in this case, our unknown was the denominator. In this case, our unknown was the numerator.